morning, everybody. My name is Chris Moore, and I am the project manager for our West Virginia University Pollution Prevention Team. Today, I have one of our students here, Mr. Connor Davis, who will be putting on a presentation about HVAC efficiency and energy use. Connor has worked 2 internships for Train Technologies, which is one of the top HVAC suppliers and manufacturers in the country. So with that, I'm going to pass this off to Connor to give this presentation. Thank you all for joining. Here's Connor.
Thank you, Dr. Moore. So good afternoon, everyone. Thank you all for being here today. I'm going to do, it's about an hour presentation on HVAC energy usage and enhancing that energy usage. So my name is Connor Davis. Like Dr. Moore said, I'm an undergraduate research assistant in the Industrial and Management Systems Engineering Department at West Virginia University. So I work with the P2 Pollution Prevention Group, and we do work with the EPA. I'm excited to share these insightful comments and analysis of HVAC and really provide some insights that you might not know already. So today we'll be covering 4 key areas essential for understanding modern HVAC systems and their role in building performance. First, we'll dive into the fundamentals of HVAC, exploring how these systems operate and the science behind them. Next, we'll examine the different types of HVAC systems available, highlighting their unique features and applications. Then, we'll take a closer look at the critical impact HVAC systems have on sustainability, energy efficiency, and operational cost, factors that are becoming increasingly important in today's environmentally conscious world. Finally, I'll offer some high-level recommendations that can help improve building sustainability, reduce energy consumption, and ultimately lower operational cost. These strategies are designed to support a more energy-efficient future while ensuring optimal comfort and performance for your facility. So starting with the basics, we're going to discuss the major components of HVAC, what they are, what they do, and everything that goes along with it. So the first section, like I just said, will cover all the key components of an HVAC system, starting with the basic principles of thermodynamics and the critical role of refrigerants in the HVAC process. We'll then explore the main components of the refrigeration cycle, including the condenser, expansion valve, evaporator, and compressor, to understand how they work together to regulate temperature. In addition, we'll look at other essential components such as the furnace, which is used for heating, and the air handler, responsible for distributing conditioned air throughout the building. Starting with thermodynamics, thermodynamics is the study of heat transfer. This forms the foundation for HVAC and refrigeration systems. While there are 3 fundamental laws of thermodynamics, today we'll primarily focus on the first. The first law of thermodynamics states that energy cannot be created or destroyed, only transformed from one form to another. This principle is key to how we move heat energy into and out of a building, depending on the season. Rather than creating cold air, air conditioning works by transferring heat, which can be a tricky concept to grasp. However, by applying this law, the entire process of HVAC becomes possible. Although the second and third laws of thermodynamics are less directly involved in the refrigeration cycle, they still define the fundamental principles of energy transfer. The most fundamental system you can understand is a residential HVAC system. Most homeowners who might be on this call might know that what the components are, maybe the indoor or outdoor units. This system consists of 2 primary units, the indoor unit and the outdoor unit, which are connected by refrigerant lines. The outdoor unit houses critical components such as the compressor and condenser, while the indoor unit includes the furnace, expansion valve, and evaporator coil. Additionally, as you can see in the image above, ductwork runs through the home, ensuring that conditioned air is effectively distributed to each room. This integrated setup is essential for maintaining a comfortable indoor environment. Moving on to refrigerant. The refrigerant is the essential working fluid in an HVAC system. It circulates throughout the system in both liquid and gas phases, acting as a medium for heat transfer and storing thermal energy throughout the cycle. Refrigerant can be stored in pressurized tanks, as you can see above, similar to like helium or any other compressed gas. These are also tightly regulated by the EPA due to their impact on the ozone layer, so they must be stored properly and in the right conditions. The most common types of refrigerant include R22, widely known as Freon, and R410A, the standard refrigerant since the 1990s. Recently, there's been a shift towards newer, more environmentally friendly options like R454B and other A2L refrigerants, which we'll get into later. The condenser is a crucial heat exchange coil in an HVAC system, typically located outside of a residential setup. Its primary function is to act as a heat dump, releasing excess heat from the home into the cooler outdoor air. As warm refrigerant flows through the condenser coil, outside air is blown over them, absorbing heat and cooling the refrigerant in the process. There are two main types of condensers: the air-cooled system, as described, which relies on ambient air for cooling, and a water-cooled system, which used water to transfer heat more efficiently in larger applications. The expansion valve, though small, is vital for regulating the flow of refrigerant through the system. It controls the amount of refrigerant entering the evaporator, ensuring it is at the correct pressure and temperature for optimal performance. By reducing the refrigerant's pressure, the valve allows it to expand and cool before entering the evaporator, where it absorbs heat and drives the cooling process. Without a properly functioning expansion valve, the refrigerant wouldn't flow smoothly or effectively, impacting the system's overall efficiency. The evaporator, designed with coils similar to those of the condenser, functions as the heat exchanger inside the home to cool the air. Typically located inside the basement or in a utility closet, this component plays a crucial role in the cooling process. As warm air from the home is drawn over the evaporator coil, the refrigerant inside absorbs heat and undergoes a phase change from a liquid to a gas. This absorption of heat cools the air, which then distributes throughout the building via ductwork. The efficient operation of this evaporator not only enhances indoor comfort, but also ensures that the refrigerant is ready to return to the compressor, completing the refrigeration cycle. Moving into the compressor, the final and most crucial component in any cooling system is the compressor, often referred to as the powerhouse of the system. Its primary role is to circulate the refrigerant throughout the system, ensuring it reaches the correct pressure and temperature necessary for effective operation in the condensing unit. There are several types of compressors used in HVAC applications, with the four main types being reciprocating, centrifugal, screw, and scroll. Each type has its own unique characteristics that is suited for different use cases, providing flexibility in system design and efficiency. Now that we went over each component individually, let's talk about the refrigeration cycle as a whole. So this slide illustrates the complete refrigeration cycle, a crucial process in HVAC systems responsible for cooling. This cycle begins in the compressor, as you can see, where the refrigerant gas is compressed, raising its pressure and temperature. Next, the high pressure gas moves to the condenser, where it releases heat to the outside air, condensing into a liquid. This liquid is then passed through the expansion valve, which reduces its pressure, causing it to cool significantly as it enters the evaporator. In the evaporator, the refrigerant absorbs heat from the indoor air, evaporating back into a gas and completing the cycle. This continuous process allows HVAC systems to maintain comfortable indoor temperatures by effectively transferring heat from inside a building to the outside environment. So HVAC is not just cooling. It's heating, ventilation, and air conditioning. So for the heating aspect, the furnace is another essential component of a complete HVAC system. This is used to heat water for space heating in the home. There are two primary types of furnaces, electric and gas. Many building owners are increasingly opting for electric furnaces due to government incentives and the associated environmental benefits. However, it's worth noting that gas furnaces typically offer higher heating capacities, making them a preferred choice for some application. Ultimately, the decision between electric and gas furnaces depends on factors such as efficiency, cost, and individual heating needs. Another component that is used in larger air conditioning units is the air handler. This unit utilizes coils to heat or cool air on each floor of a building, playing a vital role in maintaining indoor comfort. Air handlers are particularly beneficial in large buildings as they integrate the HVAC system with outdoor air intake. Equipped with a fan, they effectively distribute conditioned air through an entire floor, ensuring even temperature control and improved air quality. The combination of functions makes air handlers essential for the effective operation of HVAC systems in larger spaces. So now that we went over all the basic components, got that out of the way, we're going to go over the different types of HVAC systems. So talk about the difference between commercial and residential units and what different options there are for each. Residential HVAC units are among the most commonly used systems, and they are suitable for residential spaces as long as smaller commercial establishments like gas stations or small offices. These systems typically come in two varieties, the split system, which we discussed earlier, and the heat pump system, which is very similar. The heat pump features a similar configuration to a split system, but is reversible. This allows it to operate in both cooling and limited heating modes. Both types of units can be paired with a furnace to enhance heating capacity during the winter months, ensuring optimal comfort and efficiency throughout the year. For larger buildings such as warehouses, manufacturing facilities, schools, and offices, commercially sized HVAC systems are utilized. These systems offer greater heating and cooling capacities than residential units and can be categorized into several types, including rooftop units or RTUs, water-cooled systems, air-cooled systems, and VRV or VRF systems. Each of these systems is designed to meet the specific demands of large spaces, ensuring efficient climate control and optimal comfort for occupants. Rooftop units, commonly known as RTUs, are an all-in-one HVAC system that are installed on the roof of a building, as the name suggests. Available in various sizes, RTUs connect directly to the building's ductwork, making them applicable to different spaces. They are commonly used in smaller commercial establishments that typically require 1 to 2 RTUs, as well as larger commercial warehouses, which may utilize up to 20 or more units to effectively cool the entire space. This versatility makes RTUs one of the most widely employed HVAC systems in the industry, capable of meeting diverse heating and cooling needs. So this might be the most common type of commercial unit you've seen. They're on strip malls and all other sort of smaller establishments. For larger HVAC systems, a water-cooled system with a chiller, as shown in the center of the picture, is often ideal. This system integrates the refrigeration cycle we discussed earlier with a secondary and tertiary water loop to effectively cool the building. Water-cooled systems are more complicated and designed to handle higher cooling loads, making them suitable for demanding applications. Additionally, they require air handlers on each floor, which can increase installation and operational cost. These systems are typically used in large office buildings, hospitals, and schools, where efficient cooling is essential for maintaining a comfortable environment. So as you can see in the image above, those two loops, the secondary and tertiary water loops, are the condenser loop as shown at the top, which has a water tower on the roof of the building, and the chilled water loop is shown in the bottom, which is used to chill the water for the air handlers. In comparison to water-cooled systems, commercial air-cooled systems offer greater versatility. Typically located on the roof of a building or in a parking lot, these systems provide chilled water to air handlers on each floor, which then cool and filter the supplied outdoor air. While air-cooled systems generally have a lower cooling capacity than traditional water-cooled chiller systems, they are well suited for a variety of applications. These include smaller educational institutions, retail stores, and even restaurants, making them a flexible option for many commercial environments. One type of HVAC system that is gaining widespread adoption is the VRV, or variable refrigerant volume, and VRF, variable refrigerant flow systems. These two systems utilize similar technologies, but are produced by competing brands. These units are ductless, much like a typical home unit or rooftop unit, and do not rely on water for cooling air. A significant advantage of VRV and VRF systems is their ability to provide varying cooling and heating loads to different sections of a building. This feature makes them particularly well suited for hotels and apartment buildings where multiple tenants have diverse heating and cooling needs. And as you can see in the image, there is an outdoor unit which is then connected to a branch controller, and this branch controller is kind of the brain of the VRV and VRF system. Then it splits out and goes to the indoor units, and those are those wall cassettes that you might see in a hotel. Different rooms, rooms right next to each other, could be in heating and cooling modes. Say one tenant wants the heating because of the night, and one is just very hot, so they can get the cooling mode. As the HVAC industry shifts towards more sustainable methods of ensuring building comfort, several key topics are currently gaining significant attention. One major development is the transition to R454B and A2L refrigerants, which is more environmentally friendly alternatives to R410A. This shift is expected to become the new standard for refrigerants in the near future. Another important topic is electrification, with manufacturers and government organizations advocating for the adoption of electric furnaces and heat pump systems. These advancements aim to reduce reliance on fossil fuels, promoting a more sustainable and energy-efficient future for HVAC. So now that we know the basic types of HVAC and their components, how can you improve your building so that you have efficient and functional HVAC systems? When improving your HVAC system, it's crucial to consider both the impact on sustainability and the bottom line of your business. Two main objectives on sustainability are energy consumption and carbon emissions. Energy consumption is a key aspect of sustainability. Increased energy use often correlates with a greater reliance on non-renewable resources such as fossil fuels. In commercial buildings, HVAC systems can account for 40% or more of total energy usage, representing a significant operating cost that tends to spike during peak cooling and heating months, such as the summer and the winter. Moreover, older inefficient systems can further escalate energy consumption, leading to a higher environmental impact. Upgrading to new, more advanced systems can be beneficial in reducing energy consumption and overall cost. Carbon emissions are another critical factor in sustainability. These emissions are closely tied to fossil fuel usage and can significantly impact the environment. Fortunately, recent technological advancements have introduced hybrid and electric systems that can help reduce direct carbon emissions associated with HVAC operations. By adopting these technologies, businesses can contribute to a more sustainable future while enhancing their operational efficiency. Focusing on sustainability can yield a positive impact for your business, but it's also essential to evaluate the financial implications on your bottom line. Four major components that enable an organization to embrace sustainable HVAC practices while also enhancing business performance are energy cost, maintenance cost, employee productivity, and return on investment. Energy cost represents one of the largest operational expenses for a business. By effectively managing your energy usage, you can significantly reduce the cost. One effective strategy is to implement a variable frequency drive on large equipment, particularly compressors, which can help decrease energy consumption during non-peak loads. Proper maintenance is another critical factor that enhances the efficiency and lifespan of your HVAC equipment. Regular maintenance allows your team to anticipate replacement costs by predicting the lifespan of your system, ultimately leading to cost saving and improved performance. Employee productivity is also closely linked to HVAC performance. A comfortable work environment with effective heating and cooling systems can significantly boost employee morale and productivity, fostering a more positive view of the workplace. Lastly, it's important to consider the ROI when upgrading your HVAC system. Investing in energy-efficient technologies may require significant upfront costs, but these upgrades can lead to substantial long-term savings, making them financially viable in the long run. When considering an HVAC upgrade, it's important to balance the initial investment with long-term benefits. Upgrading often requires significant upfront capital and may disrupt current operations, as cooling systems may need to be offline temporarily. During this process, it might be suitable to do it in the fall or the spring months, because then you're not really in need of that heating or cooling. You may also need training in-house, so you could have an in-house maintenance team for the new system, or you can opt to get professional maintenance services. The energy efficiency gained over this disruption period and the training period can lead to a decreased monthly energy bill and reduced maintenance costs, resulting in significant savings over time. So you may have a temporary time where it's going to be a cost, but over time it will be a saving. Additionally, the newer systems improve occupant comfort and lower the risk of critical failure, in enhancing capital planning. Investing in energy efficient HVAC solutions also supports your sustainability goals and can increase property value, making it more appealing to future buyers and future tenants. In essence, when the initial cost may be high, the long-term advantages are substantial and really outweigh that initial investment if you are properly looking for the right system. So now we went over the reasoning for why you should upgrade and why you should make some of these improvements. We'll talk about some of the improvements themselves. So some of these key improvements that can enhance your HVAC systems efficiency and sustainability include ductwork improvements. So optimizing ductwork for better airflow and reducing energy loss. Implementing smart thermostats and building automation systems, which allow for precise temperature control and energy management. Adding VFDs, which I discussed earlier, or variable frequency drives, which can adjust energy uses based on demand in compressors and fans within the system. Air side economizers, which integrate into the outdoor system and use outdoor air for cooling instead of using the refrigeration cycle, as we discussed earlier. Water side economizers, which then leverage water temperature differentials to enhance cooling efficiency. Replacing your outdated systems through upgrading to modern, more efficient HVAC equipment. Transitioning to sustainable and A2L refrigerant systems, adopting a refrigerant that has a lower environmental impact, and then conducting routine maintenance, so implementing regular checks and services to lower your environmental impact. All of these different recommendations can contribute to a more sustainable operation and also enhance overall comfort and efficiency within your building. So one of the simplest yet most effective ways to enhance your HVAC system is by improving the ductwork and insulation of your building. In many older structures, insulation may be cracked or entirely missing, leading to significant loss of heating and cooling, as well as air leakage. Addressing these insulation issues can be relatively inexpensive depending on the current condition of your ductwork, but the benefits are substantial. In fact, investing in proper insulation can dramatically improve your system's performance. It's estimated that you can see a payback period of approximately 1 year, depending on the extent of these issues and the necessary changes. With the industry shift and the world as a whole towards AI and new technology, manufacturers are increasingly introducing smart thermostats that can be programmed to operate during working hours and enter a standby mode when the building is unoccupied. This technology can lead to substantial savings for your business, especially if your previous system was running continuously during unoccupied hours. Additionally, the latest models have made programming and usage simpler than ever with touchscreen technology and integration into your phone. In contrast to smart thermostats, building automation systems provide a more comprehensive approach to managing a building's HVAC, lighting, security, and other systems. While smart thermostats focus primarily on temperature control, VAS systems integrate multiple functions, allowing for centralized monitoring and control of various building systems. This integration enhances energy efficiency, optimizes performance, and provides valuable data analytics to help facility managers make informed decisions. Together, smart thermostats and BAS systems represent a significant advancement in creating more efficient and responsive building environments. It's important to note that the payback period for this system varies depending on if you're just installing a smart thermostat or a full BAS system, but it's approximately 1 to 2.5 years, just solely based on the idea of running during unoccupied hours and changing your scheduling of your system. Another innovation in HVAC technology is the variable frequency drive, or VFD. This advanced system connects directly to the compressor, enabling variable speed control to adjust the cooling capacity according to demand. By allowing the compressor to operate at different speeds, VFDs enhance energy efficiency and provide more precise temperature controls, leading to improved overall system performance. VFDs can often be retrofitted onto most existing systems, but are primarily utilized in rooftop units and chillers within commercial applications. This flexibility makes them a valuable addition for facilities looking to optimize their HVAC systems while reducing energy consumption. For the install of a VFD, the payback period is approximately 4 to 10 months. So it's a pretty quick turnaround for payback, just based on changing the usage of your system and really honing in on the speeds. Another effective strategy to enhancing your system's energy efficiency is by implementing an airside economizer. These units are connected to rooftop units, air handlers, or ductwork, allowing outdoor air to be utilized for cooling the building instead of relying solely on conditioned air. Airside economizers are particularly beneficial during the fall and spring months, as well as in moderate climates where the outdoor air temperature closely aligns with the desired indoor temperature. By leveraging natural ventilation, these systems can significantly reduce energy consumption, lower operational costs, and improve overall comfort within the building. The payback period for an airside economizer is approximately 2 years, depending on the retrofitting needs of your company. Here's a diagram of an airside economizer. It's important to note that these units filter outdoor air and facilitate the mixing of outdoor air with return air to achieve the desired indoor air temperature. The economizer controller serves as the system's brain, continuously measuring the temperature of the outdoor air to determine whether it can be utilized for cooling. This intelligent management ensures optimal energy efficiency while maintaining comfort within the building. It is important to note that it is all filtered, so it's not just letting outdoor air. There's always an air filter on this airside economizer. Similar to an airside economizer, a waterside economizer recycles water within the chilled water loop to cool the building. This recycled water can be utilized to cool the building while bypassing the refrigeration loop in the chiller we discussed earlier. While implementing a waterside economizer can lead to significant cost savings over time, it is important to note that the retrofitting of this equipment can be expensive. The installation process typically requires substantial equipment and piping modifications, making it a considerable investment for facilities to enhance their energy efficiency. Here's a diagram of a waterside economizer, and you can see that it combines all different loops within the building. This design features the capability to bypass the chiller, which is shown in the middle, enabling a heat exchange between the outdoor water tower's water loop and the building's water loop within the economizer. This heat exchange is crucial as it effectively prevents outdoor debris from entering the building's water loop, ensuring cleaner water circulation and maintaining system efficiency. By utilizing this innovative design, facilities can enhance their cooling efficiency while protecting their HVAC infrastructure. Waste heat recovery units are an innovative concept that can provide numerous benefits while effectively integrating into industrial buildings, such as refineries, manufacturing facilities, mining operations, or chemical plants. These units harness heat energy generated from high energy processes to warm the building during cooler months, promoting energy efficiency and reducing operational costs. Given our geography located in West Virginia, the implementation of waste heat recovery systems can be particularly advantageous. By capitalizing on this waste heat, facilities can optimize their energy use, enhance sustainability, and contribute to a more environmentally friendly operation without sacrificing day-to-day operations. So the big thing to note here is that in these refineries and manufacturing facilities, say they're processing coal, all that heat energy used for the processing is then taken up into the air conditioning system. It's making sure none of the gases are getting taken in, just the heat energy, and then being used throughout the building to heat, say, the offices or the shop floor and things like that. When HVAC systems exceed 20 years of age, it may be impactful to consider a complete replacement. Since the early 2000s, advancements in technology have significantly enhanced system efficiency and performance. Replacing an aging system can reduce maintenance costs and improve cooling efficiency, leading to substantial long-term savings. While the initial investment for a complete overhaul may be substantial, with up to a 5-year payback period or more, depending on the size of the system, size of the building, it enables your company to implement additional improvements without the complications of retrofitting existing systems. As this retrofitting can only go so far, you can only replace the compressor so many times before the whole system needs replaced. This strategic decision can ultimately lead to and provide a more reliable and effective HVAC solution that meets the evolving needs of your facility. It's important to note that replacing the whole system can really lead to a lot of benefits in the long term. And after those 20 years, you really should replace the system and look for ways to get into the next system. When evaluating the efficiency of a new HVAC system, it's important to understand the significance of SEER, or the Seasonal Energy Efficiency Ratio rating. These labels, similar to the yellow energy efficiency rating stickers found on new appliances such as refrigerators or washing machines, provide specific information about HVAC system performance. Most systems manufactured before 2005 have a low SEER rating around 10. However, as of 2023, the U.S. government mandated that all new systems must have a minimum SEER rating of 14. Many high-efficiency systems have a SEER rating of 18 to 22, representing an increased efficiency of 50% or more compared to a 20-year-old system they would replace. These enhanced efficiency translates to reduced energy consumption and lower energy bills for your facility. Transitioning to newer, more efficient refrigerants can not only enhance system performance, but also ensures that compliance with current government regulations. Many outdated refrigerants are now sold at a premium due to their discontinuation, leading to higher energy costs when repairs are needed, or higher just costs in general when repairs are needed. If your older system requires refrigerant replacement or repair due to leaks, the expenses can be significant. It's crucial to ensure that these replacements are carried out by a qualified professional to guarantee safety and compliance with industry standards. Like we noted earlier, refrigerant, if leaked improperly, can lead to ozone depletion and other environmental hazards. So it's important to do it all by the book and with a professional. Another key recommendation is the transition to A2L refrigerants. This shift is being driven by organizations such as ASHRAE, the governing body for HVAC, and the EPA. As the industry moves towards more environmentally friendly options, these A2L refrigerants are a great choice. A2L refrigerants have a lower global warming potential, or GWP, compared to traditional refrigerants, making them a more sustainable choice for cooling systems. So GWP would be how it affects the environment and the ozone layer. So all of these A2L refrigerants have a lower GWP. By adopting A2L refrigerants, your company can not only comply with evolving regulations, but also contribute to a greener future while maintaining efficient system performance. It's important to note when people talk about this A2L refrigerants that they notice the mild flammability note on them. So they are mildly flammable, but all new systems that have these A2L refrigerants have sensors and are properly manufactured so that they know if there's a leak, and this flammability is so low, it's even less than a candle or any other flammable device. Finally, routine maintenance is another big thing you can do. Routine HVAC maintenance is crucial for extending the lifespan of your system. You can reduce unexpected repair costs, improve air quality, and ensure compliance with without getting rid of your warranty. By conducting regular inspections and servicing, you can catch minor issues early, preventing them from escalating into costly repairs and minimizing downtime. Additionally, routine maintenance helps keep the system clean, significantly improving indoor air quality by reducing the accumulation of dust, allergens, and pollutants. Moreover, many HVAC manufacturers require documented maintenance to maintain warranty validity, and failing to perform these tasks can void warranties, leaving your business responsible for all repair costs, even if they're not your fault. In essence, prioritizing the routine maintenance is not only protecting your investment, but also enhancing your overall system performance and comfort. Finally, we will explore various financial vehicles for improving your HVAC system, focusing on how to effectively fund both large and small scale HVAC upgrades we just discussed. Understanding the available options is essential for making informed decisions that aligns with your budget and sustainability goals. Energy Star is one of the leading energy efficiency programs in the United States, offering numerous government-funded rebates that are detailed on their website. These rebates provided by the EPA are available for a wide range of high-efficient systems. This program primarily targets smaller systems, including heat pumps and other residential HVAC units that meet Energy Star ratings. By taking advantage of these rebates, homeowners and small business owners can save on energy costs while benefiting from financial incentives for choosing energy-efficient equipment. So Energy Star is a great program you can use not only for finding rebates. They also have many programs to track your energy usage, such as Portfolio Manager, which we have another presentation on in the future. Local businesses can also look on the westvirginia.gov website to determine if there are any extra tax credits that apply to your business. So that's a great place to start if you're looking for tax credits based on energy efficiency or other sustainability goals you are meeting. One of the most beneficial funding options is the Commercial Building Energy Efficiency Tax Deduction, also called the 179D tax deduction. This deduction can apply to any commercial company, including both private and public entities. It focuses on upgrading to energy efficient lighting, HVAC, and improvements to building envelope to avoid wasting energy. In the latest iteration of this tax deduction, changes were made to give businesses two options on receiving funding. Option one is the simpler of the two. It allows your company to receive up to $1 per square foot of your facility based on your energy savings. This deduction requires a minimum of 25% decrease in energy usage, receiving a base of 50 cents per square foot, and increasing 2 cents for every percentage increase of savings. The second option is more complex, as it requires your company to meet prevailing wage and apprenticeship requirements. These requirements will have to be approved, as working closely with your contractor to meet all requirements is a must. This option allows your company to gain up to $5 per square foot of deduction, making it impactful savings and worth all the work that goes into it. Finally, it's important to note that an energy assessment is necessary for both of these tax deductions, and it must be completed by a certified organization. You also need documentation of savings, which is very important to see how much energy savings you're having, and that can be done through Portfolio Manager with your contractor as well. So our group offers some other funding options that we can work with you to have. The West Virginia P2 group also offers some funding options through the REAP and the P2 grants. So the REAP stands for Rural Energy for America program. This is a loan financing and grant funding program for agriculture entities and rural small businesses. It allows these organizations to purchase renewable energy systems. This program is also targeted for rural states like West Virginia, as all 55 counties in the state are considered rural. When an energy assessment is completed by our team, along with recommendations for improvement, funding can total up to 75% of eligible project costs, including loans and grants. The total grant funding can cover up to 50% of the project, and loans by themselves can cover up to 75% of the project cost. So you can get that upfront funding to fund these large projects in the future. We also work with the EPA, Environmental Protection Agency, to provide pollution preventing grants in 5 areas of emphasis, including food and beverage manufacturing and processing, chemical manufacturing, processing and formulation, automotive manufacturing and maintenance, aerospace products and part manufacturing and maintenance, and metal manufacturing and fabrication. By completing an energy and waste assessment, our group can provide recommendations to help secure funding for these energy projects. Funds may vary depending on project size and other factors, but in the last 10 years, the P2 program has saved small businesses and local businesses $2.3 billion, and over 20.8 million metric tons of greenhouse gases have been eliminated. It's important to note that these P2 grants and the P2 assessment is not just an energy assessment, but a full waste assessment. So we will look at things from your water usage, energy usage, and other waste to see where you can improve your facility. So what does all of this mean for you? Your company plays a vital role in enhancing the sustainability of our state and our country as a whole. By gaining a deeper understanding of how HVAC systems function, accounting for up to 40% of a building's energy usage, you can identify opportunities for meaningful improvement. And those opportunities can be identified through things like the portfolio manager or getting an energy assessment completed. Implementing these enhancements not only contributes to the environmental conservation, but also reduces your facility's operation costs. Furthermore, with consistent maintenance and care, you can significantly expand the lifespan of your equipment, ensuring it operates efficiently for years to come.